check. Okay, let's see here. I'm gonna get the beat working, and there it goes. That should be good. Make sure it's working. Okay, sounds like it's good. Okay, so today I'm gonna implement the oversampler from the Juice DSP module, and I'm gonna also write some distortion algorithms to use with the oversampler, and yeah, see how that goes. I'm gonna make a new project in the Viator DSP repo. That okay. So let's see here. Let's make a new one. Plug in basic. Oversampling demo. And we need the Juice DSP module, of course. Oversampling demo, Let's go ahead and put a Visual Studio build in there also. Are we good? Let's see. Viator DSP for the company name. And does it say oversampling demo? It sure does. Okay, I guess that's good. Not really a whole lot to go wrong in the producer. It's pretty straightforward. And I'm not even going to use my modules. I'm just going to use the Juice stuff. And where do we start? Let's go ahead and by default, let's start using the generic audio processor editor to build our UI. So where's the editor? As editor right here. Nope, not as. This one, create editor. Yeah, of course. So like we did before, we're gonna return a new generic one. So it's Juice. Oh, no, generic audio processor editor. And just like the previous line, we do a little asterisk this. And now, let me go to my multi-stream view. You'll see two people in chat. Just want to make sure if they are from YouTube, I can actually see their chat. Okay. All right, so what do we need? We need our tree state, of course. So I'm gonna try to do that without copy and pasting. So we usually put it public and we'll say juice, I think. Audio processor. Value tree state. And then I'll call it tree state like always. I think that's correct. And then tree state doesn't have a default constructor, right? That's why I always let's see here. Let's go to documentation. Because when it's something I just copy and paste and use all the time, I kind of forget what the documentation actually says about it. Audio processor value tree state should be in there somewhere. And yeah, there's no default constructor, of course, so that's why we always go up to the constructor. And I'll say tree state. Okay. Processor to connect to this. Is it asterisk this? We'll give it a null pointer for that thing. And then the identifier that I always use is a capital parameters. And parameter layout. Oh yeah, we need a parameter layout. And I think I usually put that in private. So this one I'm gonna cheat. It's not even a plugin. That's not gonna help us. Let's do, let's see. Yeah, this one. Yeah, it's just parameter layout. Yeah, okay. So the same thing, value tree state. And then parameter layout. And then we say create param layout. Like that. We say create parameter layout. And then we have to actually, it's called create parameter layout, but we have to actually create it. And this one's so much easier to just copy and paste it between projects. But I do have to change the class name and make sure that they match right here. Params, I'm going to take all of this out except for clip input, because we need one that's going to be a bool for the oversampler to turn on and off. So I'm just going to say OS toggle. And I know this is all the boring stuff, but we got to get out of the way for our project to work. When we create a new parameter, of course, we have to give it an ID and a name. And we need to make sure that we actually push that parameter into the params vector right here. So we got to make sure they match that. And I'm going to get rid of this reserve thing. I'm going to also get rid of this. I don't think we're going to need it. Hey, what's up? Oh, QMult, you're in the, yeah, you're in the Discord. Yeah, I seen you were talking about the filters today. Yeah, I recognize you. Let me build this and see what we get. Let's see if we get an error or if my computer explodes or something. What I'm hoping is that we're just gonna have a little toggle box made for us. And this first build, of course, is gonna take longer than every other build. But I do like making new projects like this for each demo because I think it's easier to kind of keep track of, and it makes sure that none of the projects get too huge. Okay, we got a build coming up here. Look at that. Oh, wait. Oh, I'm dumb. Okay, this is what I'm gonna do. This naming convention that I use, OS toggle ID and OS toggle name, is only if those are like the variable names, but I'm passing a string, so I can just do, I'm just gonna say OS for oversample, and then for the name, capital OS. Yeah, I mean, if you already know C, I mean, it's not that big of a deal to move over to C++ and learn. I mean, it's a lot easier than somebody who doesn't know any programming at all, who's trying to learn C++ for the first time. So you should be good. C++ will give you all kinds of extra cool stuff that makes C stuff very easy. All right, we got us a little toggle button. And then what I also want to do is make sure that we're capturing this parameter. So we need to do a parameter changed method. So let's go into here. I'm going to cheat some more, get my parameter changed method right here. And also we need a listener for the parameter. So we need to inherit from that up here from public juice processor value tree state listener. Is that right? Let's see if I did it right. Yep, sure did. And then we have to actually implement the method. And I'm just going to copy this first line, give it its braces, and I got to make sure that the class name links up. Yeah, cool. And now we have a way to capture our parameter changes. So let me just make a little bool variable right here. So I'm going to say bool OS toggle is equal to false. And that way we can do an if check right here. If parameter ID, meaning the parameter that was changed, is equal to the oversample, we are going to set this OS toggle to whatever's coming in. New value. New value is probably, new value is going to be whatever the value is after the change. We're saying this is an audio parameter bool, so this is going to be true or false, but I think it actually comes in as 1 or 0 anyway. So we don't really have to cast it or anything. It should be fine, but we can check and make sure that we're getting this. So we can do a debug statement right here. Just log out to the console and get what OS toggle is after we have set it to something, have assigned it to something. Ah, yes, it doesn't like bools in here. Okay. Keep forgetting debug doesn't like the bool, so I'm just gonna do cout. Cout OS toggle, and then like that. And one more thing I didn't forget, we need to actually attach our listeners to this parameter. So again, I'm going to cheat, add parameter right here. And the parameter that we're adding is this OS right here. And then we need to also remove the parameter in the destructor to clean up that memory. And I'm gonna also take the OS thing right here. And there we go, that is it. We've created a parameter layout so that we can add parameters to our plugin, which is automatically building a UI for us with that generic audio processor editor. I am capturing the changes and doing something with those changes for the parameters, as opposed to just doing it in the process block every block. And then we're actually, we're listening to the changes right here. So we should be able to see something whenever I click the button now. All right, moment of truth. Check out the console. Oh boy, look at that. Perfect. Okay, so we're actually getting changes, which is great. We can also go into the prepare method and make sure that we're actually getting the changes at initialization. So just to be extra sure, is equal to, and then we can do tree state dot get raw parameter OS load, and that should work, right? Yep. So now at prepare to play, we're just making sure that OS toggle is in fact assigned to whatever is in the parameter layout right now, or in the tree state right now. That should work. While we're here, since we're going to be using the Juice DSP module, we need to set up our little process spec logic. So I already have that in my stream deck as a little code snippet. So let's see here. Where's it at? Prepare DSP. Look at that. Boom. Perfect. So we're going to need that for the oversampler module. So speaking of oversampler, let's go and actually check out what we have to do for it. Oversampling. Okay. Now the oversampler doesn't have a default constructor, and in fact I like using this constructor right here where you give it num channels, the size T factor, so how much oversampling, 4 times, 8 times, 16 times, whatever, and then yeah, the other stuff. So first off, we need to make an instance, so let's go into here. It's in the DSP namespace and it should be called oversampling, and wants you to give it a type name, a template type name, so float. I'm just going to call it oversampling module, and then I'm going to construct it in the CPP up here. So we can put a comma after tree state, and we could say oversampling module. So we give it a num channels, and I think by default I'm just going to say 2. Size T factor. If we look at the documentation, we see, let's see here, factor, the processing will perform 2 raised to the factor times oversampling. So by default, let's just make it 4 times oversampling. Yes. And then filter type, there's 2 filter types that you can choose for the oversampling. Right here, you can do the half band FIR EQ ripple, or you can do the half band polyphase IIR. And I always forget the difference, but at the very base level, I see one is FIR and one's IIR, and I know IIR is better on CPU, so let's use that one for now. So is that inside of the oversampler, or is that inside of? Yep, filter type, and then the IIR one. And that should be good. That's good for the constructing of the object. And I suppose we can Google, let's see. So half band polyphase. the other one? Did not match any. Really? I'm surprised there's not a more immediate result, because that's just a DSP related thing. That's not juice specific, isn't it? Let's see, half band polyphase filter. Oh, polyphase filter bank is useful in performing interpolation and decimation efficiently. Yeah, okay, so like I thought, it's going to be more efficient than the FIR version. The concept behind a decimating polyphase filter is to avoid wasted computation due to the discarding of samples. Yeah, okay, cool, whatever. That's good enough for now. So we've got that, and we also, you can see that the oversampler doesn't have a prepare method like all of the other DSP modules, and that's because instead of prepare, they use this init processing. So you just call init processing and give it the maximum number of samples. And what's really handy is if we go into the prepare method, we of course have access to the samples per block, which is really convenient. So we can say oversampling module.init processing, and we can just pass it samples per block. And that is good enough. Cool. And the way we actually use this is there's not a method that's just called process like the other DSP modules. You process the samples up and then you process the samples down. So what you would do is you would create an audio block in your process block like you were using for any other DSP module. You would call process samples up, pass it the block that you're using, and for that block it will process the samples up. You can do all of your processing that you want the oversampling to apply to, and then after you're done with that, you can process samples down to go back to your normal sampling rate. And then if you want to do anything that's not oversampled, you can put it after, or you can just, you know, have everything oversampled depending on what you want to do. So let's create an audio block. I'm going to get rid of this loop right here. So let's do an audio block called block. And then we'll say if OS toggle. So if it's on, we will say oversampling module dot process samples up and give it the block. And then we could say processing here. And then we could say oversampling module dot process samples down block. Right. And then if there's anything that we wouldn't want to include in the oversampling anyway, we could just put it outside of this if statement, probably be fine. Let's check to make sure that this works. That should be good, right? Yeah, simple enough. Okay, I think that'll work. So the way we can test to make sure this works is when we turn it on, we should see a big spike of CPU and logic, and that will definitely tell you that oversampling is happening. And right now we're doing 4 times oversampling and we're in debug mode, so that should be a pretty significant leap in CPU. So I'm gonna do this. Oh yeah, I got a CPU test project anyway. So let's do this. Get rid of all this nonsense. Remove all effect plugins. Perfect. Okay. So I'm gonna open a little CPU meter right here. And this is what it looks like. Oh, it might be too loud for the stream. Okay. So you can see, I mean, not really any CPU being utilized just to play back this audio. So let's load in, what did I call it? Probably oversampling something, right? I might just have to close Logic and reopen it. It looks like it's not there. Waveform viewers, I'm just gonna save it. And reopen it. Well, that's annoying. I'm gonna give it one more chance before I get mad. It is not there. Okay, so let's do this. It probably just wants me to restart my computer, which I'm not going to do since I'm streaming. So let's go to the folder where it is. So Vitor DSP, demos, oversampling, builds, Mac, build, debug. And this is where it is right now. So I'm actually just going to put it in the other plugin folder, because usually Logic can see what's in there without having to restart. But every time I make a change, I'm gonna have to do this, which is annoying. Let's see if that does it. Oh yeah, it's there. Okay, good. All right. So let's open the CPU test. And let me get the little CPU meter out. Cool. Let's find our plugin. Oversampling demo. Okay, so hopefully when I click this button, the CPU will spike up crazy. Yep. And then when I turn it off, it should go down. Perfect. Okay, so oversampling is definitely happening because that's a lot of CPU. So we know that oversampling is happening. Let's do that. So now what? That was pretty easy, right? We're just checking if our oversampling is turned on. And if it is, we're going to process the samples up, do whatever our processing is, passing it this block. And then when we're done, we're just going to process the samples back down. I imagine that if you don't call process samples down, it won't like it, and it'll probably break immediately because you're not processing the samples back down, and then you're going to continue the loop, and you're going to say process samples up again. So it's probably just going to go up and up and up for a couple of loops and then just break. So that wasn't difficult. Implementing the oversampler. There's a couple other things that you have access to. You can say add an oversampling stage. So it multiplies the current oversampling factor by 2. So you could say, if you wanted to make a menu that gave you different choices for oversampling, which a lot of plugins do, but I don't really see as like really that necessary. I mean, after 4 times oversampling, I don't really see the point. But if you wanted, you could make a list of different oversampling types, and then you could check to see which one and then you could probably just call add oversampling stage. Yeah, that should work. Okay. I just want to read this and see if there was anything I was missing, but I think we should be good. So it looks like this class lets us go up to 16 times oversampling, which there's absolutely no reason to go above that at all. And I don't really see the point of going above 4, because at 4 times oversampling, your sampling rate is 176,000, which means that you can accurately now represent frequencies up to 88,200, which the point of oversampling is that, you know, at 44,100, that means you can accurately represent frequencies up to 22,050 hertz. And you might say, well, we can't hear that anyway, but things like cymbals, distorted guitars are gonna have trickles of frequencies at that area. So if they go above that, they're gonna alias down, and the alias might come into the audible range. So like, there's a formula for doing this, and I did this in Max one time, but I found that you know, there were certain frequencies, probably around like 24,000, that would probably alias down to 17 to 18,000. So that's audible. Yeah. And what was I about to say? I think I found that there was no reason to go above 4 times oversampling, because if something aliased at this oversampling, it wouldn't even alias down into the audible range unless it was a super low note, which wouldn't happen anyway. But I see that, yeah, 16 times and 32 times oversampling. I mean, I feel like 32 times oversampling is just ridiculous, and it's gonna use so much CPU, because that would be, well, just close it, but that means your sampling rate would be 1.4 million, which means that you'd be able to accurately represent frequencies up to 705,000, which why? There's no reason for that. I mean, even at 4 times oversampling, that should be good enough. You could accurately represent frequencies up to 88,200 without aliasing. Cool. All right, so that's the oversampling. So let's write some distortion and see if we can hear a difference. Let's do a soft clipping first. Okay, so let's do this. We're gonna make, let's make a input knob. So let's do, this, I'm gonna say input, and it's gonna be an audio parameter float, so that should give us a slider, and we need to give it an ID, a name, a starting value, an ending value for range, and the actual starting value. So yeah, so your lowest value for the range, the highest value, and the starting value, that should work. And then we have to just pass it to the params. So that should create a slider. So let's just make sure the slider shows up. And then let's do this right here. Let's capture the changes and check it while we're there. Parameter ID equals input. Raw input, and I'm going to create a raw input. I'm going to say raw input is equal to new value. And why are you having such problem auto completing? Okay, new value. And we need to actually create or add the listener. I always forget that. Input. We need to remove the listener also. Input. Okay. And that should work. Okay, let's check the standalone and see if our little slider is there. Okay, slider is there, and we're getting our input. Awesome. Okay, cool. Let's also make a, so this is raw. Actually, I want to call this dB input and make another one called raw input. And the raw will be the actual gain. So 0 dB equals 1, a gain value of 1 being multiplied by the signal. So we'll say dB input is equal to new value, but raw input is equal to converting it from decibels to gain. Decibels to gain right there. New value. So now we might not always need it, but now we have our dB input and our raw input. Okay. Cool. Now the fun stuff. Let's do a soft clipper. I am gonna make, let's see, how should I organize this? I'm gonna move this down. Let's see, I'm gonna call this soft clip data, and I'm just gonna take in, okay, so we could do this with an audio block, or we could do this with just raw samples. It doesn't really matter. I'm gonna do it with an audio block. Oh wait, no. If you want to do an audio block, we would do a void method. So let's just do it with samples. So let's do float samples. I'm just going to implement it under the process block. Soft clip data, samples. Okay, so how do we soft clip the data? We want, so a hard clip would be basically, so we're going to be clipping off the values at a given point. And what that usually translates to is making it look like a square wave. So if you would do it to a sine wave, a hard clip would turn it into a square wave. And I just want to make sure that build works. So let's go to Desmos right here. And let's see if I can show you what the hard clip looks like. Oh wait, can I do that in Desmos for a hard clip? I know I can definitely do the soft clip, but how would I do the hard clip? Because, I mean, you can't do if statements, right? No. Yeah, let me just do the soft clip. Okay, so there's a bunch of different ways to soft clip, and all soft clipping is doing is clipping, but with a rounded edge, as opposed to the hard clip, which looks like a square. So if we want to round it out, there's a bunch of ways to do it, and the one that I like and that I always use is using an arctan function to do it. There's a bunch of different ways. You could do like a cubic clipper, you could do like a piecewise equation to do soft clipping, and they all pretty much look the same or sound the same, but you know, they're all a little bit different. So let me just do the typical soft clip, which is 2 divided by pi. I do pi. Desmos doesn't know what pi is. Yeah, okay. And then multiply that by the arctan of your signal, which for us would just be a sine wave, right? Sine of x. Yes, and then we can add a slider also. So we could say, I don't know, G. Or wait. Oh, I have to say it in here. So let's multiply it by something called G. And yeah, there we go. Now we get add a slider. So you can see, this would be, so G is 1, so that means we're multiplying the signal by 1, which would be no input or like drive or anything like that. So this is what the sine wave would look like, and you can see that it pretty much looks like a sine wave, except it's a little softer because we're multiplying it by 2 divided by pi. But if we give it some input, you can see that it starts to, no, it doesn't. Oh, of course, take it out of this one and put it after, like this. Now we should get some distortion. Yeah, look at that. Okay, so it's going up. It's squaring off a little bit, but it has a rounded edge, but it's definitely distorted because we're changing the shape of it. Yeah, perfect. Okay, so there we go. Multiplying it by 1, which means nothing. And as we go up, it's never going above 1, which would be 0 dB, but it is definitely distorting it. And instead of it being a perfect square, it's a little rounded off on the edges, so it's nice and soft clipped. Yeah, so that's pretty good. So let's implement that. So we're basically just gonna return. Let's make a const expression called const expression. We'll call it pi divisor. This will save us on a little bit of CPU. So we'll say 2 divided by, and let's get pi. I don't remember, is it in math? Math constants, yep. Float pi. There we go, pi. So instead of every sample doing 2 divided by pi, we're gonna define it at the beginning. And oh wait, const express float pi divisor, right? So we're gonna define it at the beginning and calculate it once at initialization so that we can just keep reusing it, which would save a bunch of CPU. Let's see, non-static data member cannot be const express. Okay. How's that? Is that good enough for you? There you go. Okay. So we're making a static const expression called pi divisor, which is just 2 divided by pi, instead of actually calculating that every sample. So now we can say pi divisor times, and we need the arctan, so we can get that inside of std, and it's just called atan, not arctan. And that's going to be samples times our raw gain, or raw input in our case. That's what we call it, raw input. Cool. So this is sample by sample. So we're gonna make an audio block loop right here. And we're just gonna say data sample is equal to, which is replacing what we have in the audio block right now, with soft clip data. And we're gonna give a data sample as the input. And that's pretty much it. That should be good. And we're putting this after process samples up. So it's using the same block. So we should be good right there. And then after we're done with the distortion, we're gonna process samples down. And yeah, that's it. But that's only if the oversampling is on. So if it's not on, let's see. Let's do it else. Else we just do the same distortion. So whether it's off or on, we're doing our distortion. There might be a more clever way to do this, but you know, we're just prototyping. We're just making some distortion. Doesn't really matter if it's the absolute best way to do it. So let's build that and see if we get anything. Go ahead and hit build. And you know what, while I'm here, I'm gonna make some comments, even though it's pretty much self-explanatory. But the thing about comments, a lot of people say, like, you know, don't put comments in everywhere. You don't need to put it everywhere to explain what you're doing. But I'm not really using comments to explain what I'm doing. I'm using comments for my eye to have something to lock onto to figure out where I am in the code. Because if I go line by line, obviously I understand what's going on. But if I'm looking at this real quick and there's a bunch of code on the page, the comment helps my eye latch on to something. And that's really what comments are for me. So I'm going to say if oversampling is on, process, or let's just say increase sampling rate, soft clip distortion, and then decrease sample rate. If oversampling is off, soft clip distortion. Okay, that, get rid of this dumb space right here. I'm gonna hit build again just because it's a habit. And let's go check it out in Logic and see what happens. Audio, oh, what am I doing? Open recent CPU test. So let's just make sure that the distortion works. Okay, that works. And let's see if the CPU goes up whenever we oversample. Yep, quite a bit. Oh, it seems like we're not distorting. That's weird. Okay, hold on, let's see here. It seems like when we oversample, the soft clip isn't happening. So why is that? Soft clip distortion. Oversampling is on. Oversample, process samples up. Sample, channel, block, data, soft clip data. And then decrease sample rate. Well, that's weird. Is there maybe something in this that I'm not accounting for. That shouldn't matter. That should be fine. That's weird. The logic is so simple. How can I be this bad at this? I think live debugging is probably good to see anyway. All right, let's see, oversampling. We're definitely getting our distortion, oversample on. We're not distorting anymore, which is really weird. The other thing I could do is make another. I've done this in the past, and maybe this is why. I've made another block called upsampled block. And upsampled block. Upsampled block. It seems like it wouldn't be necessary, but I mean, that's what I've done in the past, so maybe there was a reason for it. Okay, no, that wasn't it. Okay. This is really weird. If oversample is on, process sample is up, we do our soft clip. I guess I could see what the most recent thing I did was. What was the most recent thing I did with oversampling? ET Clipper, I think. If oversampling state upsample block is equal to. Oh, wait. Okay. I could do this. I wonder if this is why. So we have to say block is equal to. Okay. Okay, that's probably why I do this in between thing. Okay, so let's do this. So we're gonna make an upsampled block. Upsampled block, okay. So we're gonna say upsampled block is equal to this. And then when we process the samples down, we use the original one, right? Yes. And then for all of this processing, we say the upsampled block. Okay. So this is how my setup is on all of my other plugins. Cool. So let's check and make sure that works. Perfect. Okay, so that works. Let's take a look at this again. Okay, so what I'm saying is I have two audio blocks. One is going to be a normal one, one's going to be an upsampled block. So we're going to take upsampled block and we're going to assign it to the process samples up from the original block. And that way, any processing we do in between processing the samples up and down is going to use this upsampled block. And then when we're done with that, we just process the samples down back to block. And then if oversampling is off, now we have our original block that we're basing our processing off of, which is not affected by the processing samples up. So that's probably the issue. So let's see if we actually hear a difference with the oversampling or not. So I think the easiest way is to already have a second. Yeah, I have a copy right here. So let's remove all plugins and let's put that to 0. And let's flip the phase of this one. And this one is not flip the phase. So if I put the plugin on, both of them having oversampling off. Let me arrange this a little bit. So the first one is right here. Then we flip the phase and this one is right here. So right now they're at the same setting. Let me move the slider and just make sure that they're actually initialized. So right now they are at the same setting and their phase is flipped. So we should hear nothing, and we do. And if we move a slider, we should get something. Yep. So if I put this at 503, can I get this one to 503? Not quite, but I mean, it's close enough. We see that the logic works. So hopefully if I turn oversampling on, since the phase is flipped, we should hear a difference if the oversampling is actually making a difference. And the oversampling is making a difference, and we can hear that the frequencies that come through are very high. It almost sounds like we have a high pass filter on. So that would indicate to me that the oversampling is definitely making a difference in the higher range. But it kind of sounds like not super high. It kind of sounds like the high mid-range, like right here. So if I make a filter right here, it kind of sounded like that, right? So it's kind of like mostly this area right here that we're hearing. So that is good. The oversampling is actually doing something. Oh, let me do that. Oversample. So just so you can hear it again. So what you're hearing right now, this kind of high, mid, high sound that's coming out of here is the difference in oversampling and not oversampling. So we are getting a difference kind of in the high range, which is what, you know, people say oversampling does. So that seems to be true in our case. So good. We've got oversampling, we've got distortion. Let's see. Let's change the oversampling factor and make it like 16 times oversampling and see if the difference, or if the phase flip makes it sound any different. So let's go up here and change it from 4 times to 3 would be 8. So 4 would be 16 times oversampling. So let's build that. And this will be a ridiculous amount of CPU, especially since it's in debug mode. So CPU test. Okay, so the phase is still flipped. So let's turn this on. Doesn't really sound any different. I'm just going to go back and forth quickly, see if I can hear a difference. It sounds the same, honestly. Let's make it 2 times oversampling, which would be the least amount of CPU usage. Sounds about the same, right? Well, actually, no. I think there's less mid-range than the 4 times oversampling. Yeah, I think there's more high mid stuff on the 4 times, but going between 4 times and 16 times didn't really seem to make a difference. Okay, let's check out the CPU again. Okay, so we go here. CPU is kind of high because our plugins are in debug mode and just by default using more CPU even though there's not that much going on. So turn the plugin on, this general amount of CPU usage, and then we turn oversampling on and it goes up quite a bit. You can invert one and mix to see if they cancel. Like a different way than I just did? Because that's what I was doing. Like right here, they invert. And if I turn oversampling on, we're getting some high frequencies coming through, meaning that the oversampling is adding some high frequencies. Did you mean something different than the way I'm doing it right here? Because we can see that the oversampling is definitely giving us some high frequencies. Okay, cool, yeah. So one thing I want to do, I was keeping track of how much CPU we're using. Let's do a release build and see how much that helps us with the oversampling, just to see. It'll give us kind of an idea of what our CPU usage would look like after all the optimization and stuff of a release build. So I'm gonna let that build. Release build always takes longer because it does all the optimization and stuff. But I just wanted to have like an idea of what the CPU usage is like after the release build and optimization. And then we can compare it to a plugin, like I was about to say real plugin. I mean, my plugins are real, but you know, an actual well-known company, you know, somebody who did it very well. So I'm gonna let that release build happen, which is gonna take forever. And then I'll compare it to something, maybe, I can't think of anything off the top of my head that I have to compare it to besides, I know I have the Abasi archetype, but that's gonna, I mean, that's an amp simulator, so that's already not a good thing to compare it to because it's gonna use a lot of CPU. It's an amp sim. I mean, I don't really think I have a clipper or something that has oversampling. I don't know if you in the chat can suggest something easy I can download that's like a clipper that's free that has a oversampling in it that we can compare to real quick. I'm just wondering if this juice oversampler is as good or maybe better than making one from scratch, because if it's not any better CPU usage, I don't see the point in not using the included juice oversampling. Let's see here, CPU test, and I'm gonna turn this one off. Okay, so that's why our plugin off. Turn our plugin on, and the CPU usage doesn't really go up noticeably. Okay, let's turn oversampling on. Okay, that's not bad. Doesn't really go up that much. So let's compare it to, oh, you know what? Let me see. I have a, what's his name? Oh, I feel so bad. What's his name? Analog Obsession. I have Overdriver. Does that have oversampling? No, it doesn't seem like it. Level drive. But it is quite a bit of CPU, so does it have oversampling built into it? Let's see. Analog Obsession Overdriver. Let's see. Overdriver produces the warm, natural distortion of an overdriven tube amplifier while maintaining the subtle nuances of a player's picking, blah, blah, blah. Even booster for metal tones. Does he say anything about oversampling? Oh wait, show more. Oh wait, this isn't even his webpage. Homepage. Oh, okay. Let's go to the Patreon. This is my Patreon. Oh no, I'm just logged into my Patreon. Let's see. Where's Overdriver? Because it looks like everything is on the Patreon, not necessarily on his website. And this looks so, his plugins look so good. Like, look how awesome this interface looks. This one, I love this one. See all 64 posts. Can I search a person's posts on their Patreon? And I think this is kind of the de facto thing to compare to, because the Analog Obsession plugins are really high quality. Even though it's just, I'm pretty sure it's just that one guy by himself. He used to work, he worked for a big plugin manufacturer. I forgot what it is. So I know his stuff is really high quality. It's probably the best stuff to compare to for free. I'm just gonna see if I can find Overdriver. And he has so many things. I guess he has so many plugins that are similar. It seems like I could do more EQs and stuff, because I kind of stopped making. I really like making EQs. I don't even really know why, but I have like a Pultec clone. I have a 560 clone, and I have a is it the 550A? Is that what it's called? Clone. It seems like I could really make a bunch more. Because I mean, what's if it's free, what does it hurt to have more options, you know? Man, he has so many plugins. Am I even gonna find the Overdriver by just scrolling through? Man, is there not a way to search the posts on Patreon? I guess if I go back to my search on this page, Overdriver, let's see. We'll just put Patreon and see if it brings me to the Patreon post. Pedals, Analog Obsession on Patreon. Okay, that's that. Oh, I forgot that on Patreon you can search, you can hashtag your post. So he might have a pedal. Okay, maybe not. I'm dumb. Okay, hold up. I really want to find this. I know I'm wasting time, but I really do want to find this. Oh, look at that. Viator DSP overdrive pedal, free VST plugins. Analog Obsession overdriver. Man. Overdriver. Okay, so apparently this is before. Okay, so he used to charge for his plugins and maybe he made them free. So he used to have a web page for it, but now everything's on Patreon. Is that what I'm gathering from this? And the only reason I'm really doing this is, let's see, free distortion VSTs with oversampling. Let me just do that. Top 10 free distortion plugins. Let's see. So this one doesn't seem like it has oversampling. Okay, so Crush. I also don't see any kind of oversampling. Which is weird. It seems like oversampling is so easy to implement. Why don't all these plugins have it? Cutoff, resonance, curve, drive, saturation, level, feedback. Look, here we go. Okay, this one brings authentic tone of a single channel vintage all tube mic preamp. This might not be the best thing to compare it to because it's probably going to have more CPU usage, but modeling a tube on its own uses more CPU, just because of all of the calculations you have to do to accurately represent a tube. Because usually they're not just going to have a simple wave shaper that makes the tube wave shape, which isn't a complicated wave shape, but there's a whole long algorithm on creating a tube model that's been written about. So, you know, we've got this EQ, fat output, preset, bypass. Let's see. I mean, I've seen this one a lot, but it doesn't look like it has oversampling on. Soft tube. You need iLock for it, which is annoying. Marauder by Audio. Oh, there's already something called Marauder. I named something Marauder. That sucks. Profile, mix, drive, blah, blah, blah. I don't see anything about quality. Oh, this might not be bad. This metal zone. Does it have... It has a high quality, so let's see what it says. Let's go to the download and let's see if it says anything about...
Greetings. This time I'm going to check in UMTA guitar stomp.
Does it say anything about the quality setting? I don't want to compare it to it if the quality isn't the same. Oh, you know what? This might be a good thing to compare it to. Instead of the the metal zone one. Probably one of these more simple. So the screamer is probably going to have some filtering in it, which is the only thing that makes it different from mine, probably. Why does this say oversampling, but this one doesn't say oversampling, even though it obviously has a quality low-high? Okay, well, I'll do this one. Let's download this one. AU for Mac. I gotta put it in myself, of course. I'm not gonna complain one bit because it is free and it is high quality, so I'm not gonna complain whatsoever. See, audio, plugins, components, and let's put that in there. And of course I'm gonna have to shut down Logic. Let's pull this out. Let's shut Logic down so that it should now see this plugin. Okay, open recent CPU test. Let's see if that's in there. That was a Mercurial. Or at least I thought it was. I mean, that's what the company name is, right? That should be it. Okay, so let's see. Let's shut down Logic again and give it another chance to show me that this plugin is working. Preferences, plugin manager. Is Mercurial up here? No. All right, well, maybe I'll have to shut it down a third time. I mean, it does happen. Sometimes when I make a build, I have to shut Logic down 2 or 3 times before it sees the plugin. All right. See it. Pretty sure it should say the Mercurial. Okay, I don't see it. So I'm gonna just reset the cache. And if that doesn't work, I'm gonna just conclude that I would need to restart my computer, which I'm not gonna do while I'm streaming. So if I go to this library, I should see caches and audio unit cache. Just delete that. And then when I open up Logic, it will automatically recheck all the plugins, which you'll see right here. And all of this I'm doing just to see what my CPU usage compares to another production plugin. Let's see if that's in there now. Oh, it's not there. Okay, so damn. Yeah, it seems like I'll probably just have to restart my computer for that plugin to show up for some reason. Yeah. But I do see, if we go back to the CPU test, it's not really using that much CPU compared to if I pull in this analog obsession one driver right here, overdriver. That is using, you know, whatever that is. I mean, it sounds really good. So that's the CPU usage on that. And then if we turn mine on, it's about the same, if not a little bit less. or maybe a little bit more, but it's around, so it's not bad. And in fact, let's test it. Let's get rid of the distortion and do just the upsampling and see what that looks like on the release build. And you're definitely not going to want to do a release build while you're prototyping, or if you do, you're going to want to go back to a debug build, because it's once you start adding more and more code, these builds are going to take forever, the release builds. And you definitely don't want to be sitting around waiting for builds for that long, especially while you're prototyping. Only the good thing about doing the release builds is you'll see what your actual CPU usage is going to be like in production when other people use your plugin. That is acting crazy. All right, let's go to Logic and see what the CPU usage is like without the distortion, because this is using a certain amount of CPU. You know, we've got pi divisor as a const expression, but that is calculated at initialization, which saves us a lot of CPU. Now we've got a multiplication, and this std arctan is going to also use a certain amount of CPU. So let's see here. CPU test. So this is what our plugin is using by just being on, which is almost nothing, which is good. Oh wait, I think distortion's still there. Oh, you know what? Am I gonna have to... Oh, I'm stupid. No. It's because I left it in for when it's off. So the distortion only turns off whenever the oversampling is toggled on. So we can see if that's the case. So yeah, it's not doing anything. So no distortion. And when we're using this much CPU, okay, so most of the CPU usage is coming from the oversampling. So we can see that the compiler doing its optimization on the release build, we can see that that optimization on the distortion is hardly anything, because when the distortion was out versus when it was in wasn't really making a difference in the CPU usage on that meter. So we can see that our distortion is not costing us a lot of CPU. Part of that is we have this not calculating every sample because we've made a const expression for it. So I think that's helped a lot. And apparently std arctan doesn't use that much CPU. So it seems like we don't really have to worry about our CPU usage for the distortion. It's all coming from the oversampling, which doesn't seem that bad compared to some other plugins. So for example, if we go to Logic and let's open up something else that's not just distortion. So let's open up the Abasi archetype oversampling, or the Abasi archetype amp sim. So that is neural right here. So we can see using a lot of CPU. Oversampling is on high. If I turn it down to normal, it goes down quite a bit, but it's still using quite a bit of CPU. But that's not the greatest example, because it's also doing an amp sim, which is going to use a lot of CPU, because there's all kinds of filtering going on, all kinds of distortion algorithms going on. Also, there's going to be the IR stuff going on for the speaker emulation, which uses a lot of CPU. But we can see that our plugin seems to be okay on CPU. So I'm going to go ahead and save, take that off. I'm going to go back to doing debug builds. So I'm going to go back to edit scheme and go back to debug that. And just to make sure, I'm going to go into the project, GitHub, Guitar DSP, demos, oversampling, builds, Mac, build, and I'm gonna just, oh wait, go into release, go to where the plugin is right now, and I'm gonna delete that. And I'm gonna release the the release folder. Debug, and is debug still in there? It is not, so let's get rid of that. Looks like it probably wasn't necessary, but I'm gonna go ahead and just make another debug build, and that's probably gonna be it. We'll wait for that to build. Yep, and then I'll go into GitHub Desktop and I'll commit this for you. So I'm gonna say added oversampling demo project. Cool. That's it. So we did some oversampling and a little bit of distortion. So I hope that's useful for you all to see, to use the oversampling. I'm gonna turn this into a more tidy clip. Obviously the full stream is gonna be on YouTube, but I'm gonna turn this into a clip at some point. So yeah, thanks for watching. I think that's pretty much it for us. For that, sorry. So thanks for watching. I will turn this into a clip. Join me on Friday for the next stream. I'll come up with another thing for us to go through for the Juice framework. And yeah, thanks for watching. I'll see you next time.